We're very happy to. Okay. Well, good morning. We're very happy to have you here today for the 6th edition of the African Space Generation Workshop. I think like a few 100,000 years ago, we as humans started our first steps towards the world from Africa. And after so many great achievements, first with the Wright brothers and then with the Sputnik, we are back here on an African soil to trace like the roadmap for like to see what the universe has to offer us. I have here with me today the event managers from SGAC, part of our organizing team, and I'd like to thank them for their great work. I have also Mr. Well, sorry. Well, I would like to start with Mr. U.S. Ambassador Puneet Talwar. We're very happy to have you, and thank you for honoring our event. And we have also Mr. Abdelaziz Bourjal, Vice President in Research and Innovation from the International University of Rabat, and also Abdul Hamid, the Director of and the Council of the President. So I'll let you have an introduction with Iman, which then the event manager.
Thank you. Dear Ambassador, Directors, honorable speakers and guests, dear delegates, welcome. It is my utmost pleasure to be standing here with you today as the event manager of the 6th edition of the African Space Generation Workshop, an event that has been organized for the first time, not only in Morocco, but in North Africa. We've been working tirelessly for more than a year now on a voluntary basis, driven by our passion and dedication with the sole purpose of shaping Africa's space ecosystem in a sustainable way to ensure our beloved continent's prosperity. For years, for decades, people have always perceived space as unreachable. And even when it became possible, it still looked like a way to waste money while people are in need. So the question that has been reverberating in the collective mindset of Africans is whether or not investing in space is worth it. Well, now space is not just a luxury. Countries can afford, and it's just not for space agencies. It is for all of us. We are all space users. From connectivity and GPS to financial transactions, we are all space users, and that's the starting point. Now, that being said, the space sector may seem very far from our reality, but it brings enormous benefits to humanity in terms of instant access to information, water resources management, and agriculture. Therefore, if Africa aspires to meet the needs of its growing population and the achievement of self-sufficiency and sustainable development, investment in space technologies is unavoidable. We have a lot of work ahead, but we are very optimistic about how space can improve the future of our continent, more precisely to make sure that everyone can reliably and safely use the shared highway we call space. Conquering space, just like our ancestors conquered the world, is indeed a beautiful idea, but the main goal is not to just explore and get out of the crater we are living in now called Earth, but is to make our home planet better. Fear not, we're not alone in this. Achieving a sustainable space ecosystem for the African continent is not only Africa's responsibility, it is everyone's. And we can clearly witness this through the amount of support and sponsorship our event received from the 4 corners of the world. And this highlights the importance placed on seeing Africa rise in this field by the whole space community. With new space and private companies taking the lead, it is a huge opportunity we as Africans must seize. To take a step further in the space industry, unlock our full potential, and achieve prosperity by bringing all the benefits of space down to Earth. Starting with this event and a short view of the layout of these 2 days, we will be hosting a variety of simulating panels and keynotes to tackle a comprehensive list of the different aspects of the space industry, ranging from climate change to metaverse, from propellants to space policies and strategies, and from capacity building to commercial space. This being said, throughout these 2 days, we're not only looking for capacity building, but we're also establishing the roadmap of an African sustainable space ecosystem through the recommendations our delegates and experts will suggest to the United Nations as an outcome of the working groups. Now, dear co-organizers, partners, thank you for lending us a shoulder to be able to carry on this event on its 6th edition. Dear sponsors, thank you for trusting our vision, our event, and our team. Dear speakers, thank you for accepting the invitation and for coming miles away from your home to share with us your expertise. We are looking forward to a great event full of exchanges, knowledge sharing, and great networking thanks to you. Dear delegates, I hope you will make the most out of these 2 days to meet like-minded people, network, enrich your knowledge, and most importantly, voice your thoughts. We need you. Africa needs you, and the world is counting on you. This wouldn't have also been possible at all without the funding and generosity of our sponsors. So I really want to take the time to acknowledge all of our partners who have supported us, notably the Moroccan Initiative for Space Industry, the US Embassy for Morocco, and the International University for Bats, and of course, Traiteur Samra. Our Majara sponsors, Meta Visionaries, our Najma sponsors, Ground Space, Nicomatic, Redal, and Mrs. Temiabi, and our COCAB sponsors, Cube Space, RIIS, New Space Systems, ACE, and GGPAN. On behalf of the whole organizing team, I cannot stress enough how grateful we all are for your support. I also want to take the time to shed the light on the whole organizing team who have been working tirelessly for over a year, dedicating their time and efforts to the success of this event, with a special thank you to our Deputy Event Manager, Iman. In hopes of bringing the space perspective to decision-making, we are now on the lookout for the engagement of people from all fields to help us reach the vision of achieving the prosperity of our continent through space technology advancement. Until then, ad astra per espera. Thank you.
Thank you, Wisdom, for these amazing words. It's really inspiring. Now I'd like to leave you with a word from Iman. She has something to tell you.
Thank you, Sarhan. Thank you, Wisdom. Thank you, everyone. Your Excellency, the Ambassador of the United States. Dear representative of the International University of Rabat, dear Moroccan Initiative for the Space Industry, distinguished speakers and distinguished delegates, thank you for being here. First of all, for our internationals, welcome to Morocco. مرحبا بكم في المغرب. Once again, and after, of course, our incredible event manager, I would like to thank you for coming to the 6th African Space Generation Workshop. So this year, it is, of course, hosted in Morocco. And Morocco has been, throughout history, a melting pot for cultures and civilizations and trade. And it is now also the bridge of Africa to the internationals and also now to space, specifically through events like the 6th African Space Generation Workshop. So not only because of its geographical position, but also thanks to the excellent diplomatic relations that the country has. Therefore, it is indeed the best opportunity to hold the first African Space Generation Workshop of Northern Africa in Morocco. So, in terms of space capabilities, Morocco have been a space actor since 1989 through CRTS, which is the Centre Royal de Télédétection Spatiale, which is the institution responsible of promoting and using the remote sensing applications in the kingdom. It is also behind the first Moroccan satellite, which is Maroc CubeSat, also known as Zarqa Yamama, which was launched in 2011. And then Morocco has now a constellation of 2 satellites operating. They're called Mohammed VI-A and Mohammed VI-B, in tribute to His Majesty the King of Morocco, Mohammed VI. As for the continental level, the African continent, the countries in it are doing a tremendous work. To date, 52 different satellites of 14 different countries were launched, and several are coming on the coming years. So the future is now, and we are the future, dear delegates. The African Space Agency is also starting its activity to facilitate the strategies, projects, and policies to be adopted continentally, making the whole continent an important actor in the space industry. Hence, amongst many of us here, dear delegates, future leaders, policy specialists, decision makers, they will be shaping our continent of tomorrow, the Africa we want, a sustainable and prosperous Africa. Indeed, innovation, capacity building, and scientific research are the main gears for economic growth, thus prosperity, which is also the theme of this year's 6th African Space Generation Workshop. So, notwithstanding, with the richness of Africa in terms of youth, the skyrocketing in the industry we are witnessing this last decade in the continent, and the African Space Agency starting soon, the whole organizing team worked tirelessly to prepare for you a rich program that's going to shape your vision on the future of the industry, whether it is in terms of capacity building, commercial space, strategies, policy, or visions. So it is the reason why I would like to thank once again our distinguished speakers, which are very international this year, coming from different backgrounds, private, civil, defense, academic, and professional actors, representing the European Space Agency, the Portuguese Space Agency, GMS in Africa, Egyptian Space Agency, GGPN, and NASA, of course, with Dr. Eric Smith, for which we would like to thank the US Embassy in Morocco and Your Excellency, Mr. Ambassador. We would also like to thank once again our sponsors, which make all of this happen today. We have been working tirelessly for a year now to make you proud, and thank you so much for your confidence in us and for supporting us all along the way. And of course, a special thank you to the Université Internationale de Rabat, with a special shout out to Mr. Deber, Mr. Biljoued, and Mr. President, which is not here with us, and of course, Mrs. Brigitte Jamart. So, the 6th African Space Generation Workshop, within those 2 days, will provide you an unparalleled opportunity for you, future leaders of the African space sector, to proactively establish strong relationships internationally, exchange ideas and knowledge, and collaborate on novel ways in which space technology can be utilized for the benefit of Africa. All discussions from the working groups are expected to produce recommendations to relevant public, private, and non-governmental sectors, helping to shape our Africa. The reports and recommendations from the panels and working groups will be presented at high-level conferences and included in the Space Generation Advisory Council annual report submitted to the United Nations Committee on the Peaceful Use of Outer Space, UNCUPOS. And with the coming inauguration of the African Space Agency, it is indeed the opportunity to be part of this change, hence achieve the Africa we want and the UN Sustainable Development Goals, which will only be possible through technology transfer and knowledge transfer on an international level. From Africa to Africa, and Morocco being the springboard. So, we would like to thank you so much again, and we would like to declare the 6th edition of the African Space Generation officially open. مرحبا بكم.
Thank you, Iman. And now we'll move forward with a word from Mr. Abdelaziz Benjouad, the Vice President of the International University of Rabat.
Thank you very much. I want just to welcome to His Excellency, the President, the Ambassador of the United States of America in Morocco. Very happy to have you among us for this event. And I would like to congratulate all the organizers, the students, our students, and also to welcome all the assistants here. And very happy to see all these people here for this 6th African meeting, workshop about space. And on behalf of the President, Mr. Muad'Dib, who will not be with us today, I will give the floor to my colleague Abdelhafid Dabbagh to say some words on behalf of the President of the University, International University of Rabat. Thank you very much.
Thank you very much. I will speak on behalf of Professor Nourdin Muad'Dib, President of International University of Rabat, and starting by making some apologies from him because he couldn't make it because of some small health issues. Mr. the Ambassador, Your Excellency, we are very honored to have you visit our university after your appointment as Ambassador of the USA in Morocco. We are very glad to have you here, and Mr. the President is extending his official invitation for you to come for sharing your views with our students very quickly. Dear representatives of the ministries, honorable guests and speakers, invitees for the 6th African Space Generation workshop, dear member of the organizing committee, very dynamic, enthusiastic, and entrepreneurs, dear students, ladies and gentlemen, I am very honored to welcome you at the International University of Rabat for this 6th African Conference of Space Generation that will be held by our university during the 2 days of 25th and 26th November 2022. I would like first to congratulate the organizing committee, the event managers, for their dynamic, for their entrepreneurship, and for their excellent organization of this workshop. Would like also to thank the Executive Council of Space Generation, the Space Generation Advisory Council, for the confidence to organize this African conference here in our university. In fact, the contribution and of our university to this workshop does confirm our strategy to contribute to capacity building in the space domain. We have, since the university has opened its door in 2010, chosen to develop a curricula especially for space engineering, aerospace engineering, in partnership and dual diploma with two American universities, well-known, Mississippi State University and Georgia Tech, with whom we have developed the curricula and also mobility for our students to spend 3 semesters or 2 years getting their diploma. In fact, we have been very proud to see the best performance and the excellency of our students with GPA from 3.6 to 4 during their studies in Georgia and Mississippi. Up to date, we have graduated more than 330 students, out of which 125 have been enrolled in Mississippi and Georgia Tech for their dual diploma. Not only that, but 35 of them have gone through PhD studies and got their PhDs with a very high level of excellency. I'm very proud to announce today that UR got also her talent in the person of Miss Munia Malki, who has been our graduate of double graduate of our university and Mississippi, PhD doctorate, and has been hired by our university. Our graduates are hired by many agencies at the national level, research, as well as satellite development, but also they are hired at the international level in France, in the United States, and other countries. The aerospace or the space sector is also well developed here in the domain of research, applied research, and innovation. Indeed, we have a strong laboratory on material called LERMA, where multidisciplinary research team works on various thematics related to aerodynamics, related to control technique for enhancing aerodynamic characteristic, working on material composition for the various engines of space and aerospace, and also on aeroacoustics. Other teams, thematic will be developed very shortly, especially in relationship with our partners in the States, Mississippi, as well as GTL and other institutions, but also will meet the need of Moroccan research development to contribute to the space, the application development in the country. This will comfort our vision in terms of contributing to research development, application, as well as innovation as a gene of our university. At the end, I will say we are very happy to host this workshop, and we are looking forward for your for a recommendation and outcomes, and I hope all the success for your workshop. Thank you very much for your attention. The word was written in French, and I did translate it directly in English.
Thank you, Mr. Tepa. Well, now I'd like to leave you with a word from a representative of a very promising initiative. It's called the Moroccan Initiative for Space Industries. I'll leave you with James Benouda.
Good morning, Your Excellency, honorable professors, distinguished speakers, delegates, and guests. Thank you to each and every one of you for being here with us today. Let me, on behalf of MISI, the Moroccan Initiative for Space Industry, express gratitude to our partners and sponsors in this event, namely the UAR, the United States Embassy, and Meta Visionaries, as well as all our other sponsors. Not so long ago, MISI gathered as an initiative of Moroccan scientists, aerospace engineers, entrepreneurs, and educators from Morocco and abroad around the belief that STEM education and space industry are key elements in the making of tomorrow for Morocco and all of Africa. From Africa, the cradle of humankind, to the stars, Ad Astra. Thank you.
Thank you, James. So we're going to close our welcoming speech by we're very honored to have the Mr. U.S. Ambassador of United States of America. Please, the stage is for you.
Good morning. Thank you so much for having me at this wonderful event. I arrived in Morocco just a week ago, and I think my timing was perfect because this allows me to be with you on a subject and an event that is in an area that is one of my greatest personal passions, as my wife, Dr. Sattar, and my son, Ilyas, can let you know about. They've heard me talk about it often at home. So it's just wonderful to be with you. And thank you so much to the UIR as well, and to all of the others who are involved in this event, and Wujdan, that was a really remarkable set of remarks you made, and very inspiring. Today you're going to have the opportunity to learn about how Morocco, countries across Africa, other international friends like the United States, are working together to expand humankind's knowledge of our vast universe. And I'm so pleased to hear from one of NASA's brightest scientists, Dr. Eric Smith. And I know you will be hearing from many other scientists over the coming days as well, including Dr. Green, who will be joining remotely. From the beginning of human history, humans have looked up to the night sky with wonder. And thanks to dedicated people like Dr. Smith, who have been working for decades in engineering and on scientific marvels, we can look to the sky with new understanding. Space exploration is essential to our way of life. The scientific innovations it has developed now help power our economy. They advance our understanding of the Earth, the universe, and humanity. They help us manage our resources, protect people, property, and the environment from extreme weather events, and they're helping to address the climate crisis. But space exploration also gives us a new perspective on this planet that we share. It helps us understand how unique it is and how important it is that we work together to preserve it. It also inspires us to pursue our dreams. It attracts people from across my country, America, and as we see here today, from all around the world, to engage in science, technology, engineering, and mathematics, STEM. We are on the cusp of historic changes that have the potential to bring the benefits of space to more people and communities than ever before. When NASA launched the Hubble Space Telescope in 1990, we were able to see the stars unobstructed by Earth's atmosphere and understand the universe in ways we could never have imagined. And now we enter a new phase of scientific discovery. Building on the legacy of Hubble, the James Webb Space Telescope allows us to see deeper into space and earlier into time than ever before with stunning clarity. It will enhance what we know about the origins of our universe, our solar system, and possibly life itself. This was made possible because of an extraordinary partnership among nations, and it is an example of how science can bring us together to achieve remarkable things. This telescope is one of humanity's greatest engineering achievements, and the images we have been able to see are a testament to the amazing work done by the thousands of workers who dedicated years to this project. Space exploration continues to intrigue and inspire us as well. Just last week, NASA launched the first Artemis mission, a test of the Orion spacecraft. Ultimately, Artemis will bring humans back to the lunar surface for the first time, something we haven't done in 50 years. So thank you again to the organizers. I look forward to hearing more about the future of space from the experts here today.
Thank you. We're very honored by these words. And now I know like the program is full of many speeches, many panel discussions. So I have next here a keynote speech by Naufal Sweetat, and he's going to talk about space education outreach through hands-on projects. All right, yeah, sorry, there has been a change in the program. So, yeah, so welcome Dr. Eric Smith, the program scientist for the James Webb Telescope. Thank you. Thank you. Dr. Eric is going to talk about a new era of astronomy for all and why we built the James Webb Telescope. I personally, once I saw the mission of the James Webb Telescope in the first picture, I described it as it being the photograph professional being hired by the universe to restore old pictures of itself. So I'll leave you with the keynote speech. We're gonna do the setup, and I hope you enjoy it.
Thank you very much, Sarhan. Thanks to Mr. Ambassador, the U.S. Embassy, for helping to enable me to come here. Thank you to the UIR for hosting this event. And thank you for your inspiration that you are actually providing to the older generation, seeing your involvement in astronomy and space itself. Now, the organizers and I didn't collaborate on what my talk title would be, but I actually titled it A New Era of Astronomy for All, just as the organizers talked about a new era of space for all. And I think is this the clicker I should use?
I suppose.
Yeah, see. Yeah, let me back up here. So again, unbeknownst to me, the theme that the organizers would have, this is the title that I chose here. And I'll tell you a little bit about why I really believe Webb is the beginning of this new era of space for all. So why do we build space telescopes in the first place? So you see up here 4 images of new ways of looking at the sky. Every time we put up a new telescope, we get a new set of eyes on the universe. In the top left, there's a picture of the Crab Nebula as seen through the X-ray eyes of the Chandra X-ray Observatory. On the upper right, Zeta Ophiuchi and the image on the lower left are now famous images from the Hubble Space Telescope, which was one of the first telescopes that introduced us to the power of space observation. And then the bottom right is a pair of colliding galaxies where we have 3 of our space telescopes collaborating, if you will, an X-ray Observatory Chandra, the Spitzer Space Telescope, and the Hubble Space Telescope to give us a view of all the physical phenomena that are happening in these interacting galaxies. So we go to space to get new eyes, and we build new observatories to see the universe anew each time. But why did we build the James Webb Space Telescope? We built it, oddly enough, because of what is not in this picture. When Hubble stared very deeply into space, the first time in the mid-1990s, and this image here comes from 2014, the Hubble Ultra Deep Field, Hubble was seeking something that humanity had sought for most of the 20th century. We looked ever farther into space to find the first stars and galaxies to form after the Big Bang. Well, I mean, why should we care? What does that do for anyone to know this? From the Big Bang to about 380,000 years afterward, we understand how the universe changed and evolved very well. Theories comport with observations very precisely. With telescopes like Hubble or large ground-based telescopes, we can see back to when the universe was around 500 million years old, and it has galaxies much like those around us locally today. So somehow between 300,000 years and 500 million years, the universe as we know it came into being. It's as if you had family photographs of a sonogram before the baby was born, and then family photos back to when they were maybe a teenager. Something important has happened in between those two photographs. And that's what we're seeking with Webb, is to find out how that smooth universe that came out of the Big Bang gets turned into the discrete and beautiful universe we see here. So I mentioned the Hubble Space Telescope, and many people are familiar with it. And so I just have this chart to show the primary differences, the physical differences of James Webb compared with Hubble. So one, it's much larger. And the second most important characteristic is that it is infrared optimized. We needed to see infrared radiation, heat radiation with Webb, because those very first stars and galaxies are going to be best detected in the infrared. The light that left them was visible and ultraviolet when it started out, but through the expansion of the universe, it has been stretched into the infrared part of the spectrum. So to see these very faint, small objects, we need a bigger mirror, and we need to be infrared optimized, excuse me, to best detect that. So here graphically is just where we're aiming in cosmic time. You can see that Webb or Hubble goes back to more or less the modern galaxies we see. They look like our own galaxies, maybe a little bit clumpier. That would be for the very active star formation that's going on. But they nevertheless are primarily like ones today. So we needed the Webb to go back from that 500 million to around 200 million years after the Big Bang, when current theories say the first stars and galaxies should form. But as an observational astronomer, I love finding observations that make the theorists go back and do their work again. And so hopefully what we're finding with Webb will challenge some of those theories. Now, this is a movie. I don't know if it's going to play because of the old Mac PC conundrum. Ah, it is. So this is a little movie about the launch. Here we are riding an elevator up aside the Ariane 5 launch vehicle. I'll talk a little bit more about Ariane. And this was just before we began encapsulation. So you ride this elevator up, and at the top sits this magnificent gold and silver telescope about to be encapsulated. Here you see the rather nerve-wracking process when they were moving the payload around, putting it on there. Then they dropped the shroud over it, and there's just a couple inches of clearance on both sides as they were lowering that shroud. That was a nail-biting moment when they were doing that. But eventually that worked well, of course. And here we are rolling out of the facility in Kourou in French Guiana. It is in the rainforest. It rains there. And now this is now launch day, December 25th, 2021. And if you heard the sound, you would have heard décollage right there. Now this clip ends with the release of James Webb by the Ariane. We're very grateful actually to the European Space Agency, because they put these cameras on, which were actually for Ariane 6. They put one on early for us here. And our first indication of how good things were going to be were when that solar array came out. It wasn't supposed to come out for several minutes because we anticipated we would have to correct our orbital insertion with our own rockets. But the fact that it came out meant that the injection was so perfect, we didn't have to execute. We didn't use any fuel. And that gave us a mission that's going to last 4 times the requirement and twice the expected lifetime. So we can't thank Arianespace enough. Yeah. And that it also, to me, that was very emotional. It was like the telescope signaling, I'm good. Another important point that, again, the organizers made, this is a map showing where hardware or significant software components came from Webb. So it came from 29 states within the United States, of course, Canada, and many countries in Europe. It takes a world to build a telescope as complex and as powerful as Webb. Some 20,000 people worked over those nearly 3 decades to make Webb happen. Of course, Webb will not be the final telescope. There will be future telescopes even more powerful than Webb. And those more powerful telescopes will need dots over more places in this map. When the next big telescope comes up, I certainly hope there is a dot or more than one dot where Morocco sits, because you are going to be the participants in that future great observatory. While Webb is designed to look for the very first galaxies, the next one we are contemplating building will actually search for life. And we want you, we need you to be a part of that. So many of you saw this image. This came out on July 12th of this year. This was one of the first indications of just how well Webb was working. We are exceeding requirements in virtually every way you can measure them. Sharper vision, more sensitive, more lifetime, more stable, better pointing. It's almost embarrassing how good the telescope is. This is, of course, we call it the cosmic cliffs. It's where stars are being formed in our own galaxy. Many of you saw this image comparing the very famous picture known as the Pillars of Creation in the Eagle Nebula from Hubble and Webb's view. The infrared vision allows you to see through some of the dust that obscures stars there on the left. And these type images from Webb have galaxies in almost every one. So in many of those objects in the background are galaxies. This image was just released, and this is a protostar. It may be a little hard to see, but in the center, right there, you can see there is a little black line going through the bright emission part. This is a young star system that is forming. The disk of dust is obscuring light from getting directly to us, but the light of that protostar is already illuminating the gas that continues to collapse down, forming a new solar system right there. And of course, we built Webb to find the things in the distant universe. And here's something known as Pandoras Cluster. Again, almost everything you see, except for this is a star. Anytime you see things with 6 spikes in it, that's an image that came from Webb. So that's a star, but everything else is a galaxy. Hundreds of billions of stars, thousands of them in this image. And when Webb looks at the sky, we look at a piece of the sky about the size of a coffee straw, if you look through it. So multiply that across the sky. And 2 pieces that are called out here, this galaxy here at what astronomers call a redshift of 10, and this one a redshift of 12. That's a measure of the distance. The farthest thing we had seen with Hubble was at around a redshift of 10, and already with Webb, just within a fraction of its first year, we have seen something at a redshift of 12.5. So we've seen farther. We are now starting to press on those theories that people have for how galaxies were formed. And we may need to revise, because the universe, it seems to have known how to build galaxies a little faster than we thought. But of course, we're just figuring out how the universe works. It actually runs the show. And another thing, although we didn't build Webb to study exoplanets, it turns out it actually is a very powerful observatory for doing so. And just this week, on Monday, in fact, these results were released showing the spectrum of a planet that orbits a star in a system known as WASP 39b. The planet is B, just known as B here. It's a Saturn-sized planet, Saturn mass planet that orbits its star closer than the orbit of Mercury in our own system. But the important thing here are all the complex molecules we can see in this system. Now, this isn't a habitable planet. No, no one is going to be living there, but Webb will observe planets that are in the habitable zone. And so not only will we be able to study habitable zone planets, we have one in our own system, Earth, but we will see a diversity of worlds now. And this, I think, will be very important for our own understanding of how the Earth's system changes over time, because we have only one snapshot with Earth, but soon we will have other examples of how habitable atmospheres can evolve. So I think that's really exciting. And although this isn't my field, I think this is where some of the real textbook breaking things will come from Webb. You can, of course, follow what Webb is doing via the social media or on those two links down there. We are publishing, papers are being published at a rate, or I'll say being submitted to the preprint archives at a rate of about 3 or 4 a day on Webb. So the fact that we have open science, the data from Webb is always available to anyone in the world 1 year after it, but increasingly, in fact, 2,000 hours of the 6,000 hours from the first year are available to the world immediately. So this openness of data is really driving acceleration of scientific discovery. And that is something that you might say, well, what does the US gain out of this if people all over the world are using these data? Well, knowledge doesn't really know about the boundaries we draw on maps. So knowledge that we get from the universe, regardless of where it comes from, benefits the US taxpayer and the rest of the world. So open science and open data is very important to us. So that is my last slide. I am, again, thrilled to be here to see all you have to offer, because you will shape the future of space exploration, not only in astronomy, but in other fields as well. So thank you very much.
Hello. Well.
Yeah, the mic.
Yeah. Thank you, Dr. Eric. I know that many of you have so many questions. I know that no matter how much time we have, it will not be enough to answer all these questions. But we would like to have 1-2 questions from you, if you have any. And of course, our honorable speakers will always be available to answer your questions during the event.
Thank you for the presentation. You talked about a Saturn-size planet, an exoplanet, and how we are studying its atmosphere. How can we be sure that that's the atmosphere and not like a ring system or maybe moons orbiting such a big planet?
The way this system was discovered was through what's called the transit method, where you first watch how a star's brightness changes over time, and you see a little dip as the planet passes in front of the system. So then you can see that dip, it isn't a sharp edge. It goes down gradually, and that's the effect of an atmosphere gradually blocking the light and absorbing it from the system. And because of the detail of the spectra, you can actually begin to get pressure models of the atmosphere. And so that's how we know it's not necessarily a ring system, which would be a more sharp boundary, but rather something that has a pressure gradient. And so we see that it's getting thicker, and we can actually measure there are clouds on that planet. So maybe someday there'll be a weather forecast for WASP 39b. I see two questions here.
First, I'd like to thank you for the great speech. I have a question. Can you please tell us more about gravitational lens and how we got to see that for the first time with Webb?
Yes, in fact, one of the first images that was released from Webb made use of a gravitational lens. And what a gravitational lens is if you have a cluster of galaxies, so many thousands of galaxies, which are very massive, and they in fact sit in dark matter wells that have gravity also, and anything that is behind those systems, from our point of view, the light coming from those distant sources is bent by the gravitational lens, just as a physical lens. That bending magnifies and distorts the objects behind it. And so when you see an image that uses gravitational lens, you'll see these arcs often that look like they're circularly symmetric around the center. So we can use how those images appear how they are stretched. If you see one image here and another image here of the same galaxy, tells you about the mass distribution. So we use it to learn about dark matter between us and the distant system, but because it actually magnifies the objects that are behind the gravitational lens, we can use it to see farther than we would have been able to. So we're actually using nature, we're being assisted by nature, seeing some of the most distant objects. When right before Webb was launched, the Space Telescope Science Institute did a program of looking at more gravitational cluster regions of the sky. So we had more nature's telescopes to use. It's a very powerful technique. There's a question in the back.
Okay, we're running out of time, but yeah, we can.
Okay, first of all, thank you for the interesting presentation and the hard work you did with the team in NASA to bring these beautiful images to us. Thank you. I have a question regarding the computational and the energy and time needed to get these images to be published. Like how much time do you need to download the image, collect the image, and work on them to get these features out? Thank you.
The images come back about twice a day. We have ground links when we pass the deep space network, and so we can either store them until then. So twice a day we get a data dump down, and then the pipeline that processes those data takes about maybe an hour or so before it goes into an archive in a preliminary state. Then additional data processing can happen either at the discretion of the principal investigator who proposed that, or anyone who has access to the pipeline software. And in an innovation, all the software we use to publish Webb data is open source. So you can improve the software that the Space Telescope Science Institute uses. It's available for anyone to see so they can understand how did those electrons get turned into my picture. You can understand every step of the way. And we think that's important. Not only should you give people the data, but you should tell them how you actually turned those electrons into astronomical information. So the whole process is actually pretty quick. In fact, the exposures are typically much longer than the time it takes the data to get down and get processed.
All right, thank you so much. The event manager, Wijdan, and Iman would like to stress their appreciation and thankfulness toward our partners, especially the U.S. Embassy.
Exactly. We just want to take the time. Once again, I feel like everyone was astonished by the beautiful images that James Webb has provided us with, and learn more about the history behind this project. And I just want to mention again that without the support of the US Embassy, we wouldn't have been able to have Dr. Smith with us. And we will also have honored to not only receive Mr. the Ambassador here, but also his wife and his son, Dr. Sitar and Mr. Elias. It's a great pleasure to have you here with us. Thank you so much for taking the time to accept the invite and to come. We really appreciate it.
Once again, I would like to stress the fact that we are honored to have everyone here from the U.S. Embassy, Dr. Sattar, the Mr. Excellency, and Mr. Elias, and thank you so much. Please enjoy the 6th African Space Generation Workshop.
So next, we're having a keynote speech by representative of the Moroccan Initiative for Space Industries, and he's going to talk about some hands-on project, a project that made its way to the International Space Station recently.
Hello, everyone. Welcome to the 6th Space Generation African Workshop. While he's setting up, I just want to say it is extremely wonderful that I'm here in my background. I used to play here on this ground. I used to play soccer. I used to pick up balut. And here I am about to speak about space. How wonderful is that? I never thought in a million years that I'll be here speaking about space. Having U.S. Ambassador, Dr. Eric, and all of you actually from all over the world. I can't express how excited I am. For you, for us, for Morocco, for Africa. It's amazing. Well, I'm Naufal Souitat. I am one of the founding members of the Moroccan Initiative for Space Industry, along with wonderful people. They're sitting right there. Yeah. I also work on mainly heliophysics space missions with NASA, the Goddard Center, and other, not just heliophysics, mainly. I work on the fabrication, assembly of instruments and spacecrafts, and make sure they actually work when they go to space. It is tough for me to give a speech after Dr. Eric's speech. I did not sign up for that. How can you even top anything like this? But to make it, to launch something like James Webb Telescope, you got to start somewhere. And that somewhere is education. Middle schools, high schools, that's where everything starts. And if you don't build that base, you're not going to go anywhere. So that's why, as the Moroccan Initiative for Space Industry, our mission, while we wait for the regulatory frames to take shape here in this country, we're working with students from all levels. We actually did projects with students here. 4 students graduated the master's thesis with a project that we work with them, and there is a display outside at the MESI stand that our friend James made with his hand. Please take a look in between sessions. And we work with high school students, and one of the projects was called ExoLab Morocco 1. ExoLab is in 10th version. It's been launched to space 4 times. And we did a pilot project last year for the first time with 2 high schools in Gulmim from the Sahara, which was amazing for them and for us to work with underserved communities and bring space education to them. With that as so that's the ExoLab there, and I'll tell you all about it in a little bit, and I'll try to keep it short and sweet. How do you move this thing, Serhan?
I'm not the expert, but maybe we can use the buttons.
Some button. No, that's the thing.
I can stay here.
Okay. So as I said, as MESI, we decided to work for to improve STEM education in Morocco. We started with ExoLab Morocco 1. Next slide. So what is the problem? As you can see in the charts over there, in Morocco, 48% are asked to memorize science. That's a statement by the World Bank. That's a problem. And you can see on the chart over there, so our scores in the PISA were way below the average. The average is around the 400 points. We're in the 300s. In the second chart, our share for top of any field is nothing. And our share for the lowest score It's pretty high. That's a problem. It's okay. We need to recognize the problem to fix it. We cannot just pretend everything is okay. We need to look at it, take a hard look at it, and we work to fix it. Our governments are working hard. They're doing what they can. But the civil organizations need to help. And that's where we're here. Next, please. Again, more not so good data. Enough of bad news, let's move on. So, space education. Why do we think space education will help fix the STEM problem? Well, no, go back. So, every child in every country, in every continent, looked at the sky and wondered. No borders, as Dr. Eric said earlier. Every child looked at. So space education ignite that curiosity, keeps it alive, because we all get a little older and we get busy with life, with math, homework, and physics in high school, and we forget about that curiosity. But if you include space education in your system, you keep it lit, and it's gonna take you something. STEM education connect to STEM careers, where every nation needs it. There is not a single nation that can be prosperous without STEM education or STEM careers. We're all using technology. So you can choose to be a consumer, or you can join the production and be part of it, part of the innovation and part of the future. And as we all said, Dr. Eric, our organization members, this is a new era of space generation. We just launched Artemis. We're looking at building permanent bases in the moon, maybe sending humans to Mars soon. Some of us here are part of the Apollo generation, and the next generation is Artemis generation. And it is imperative that we include space education in our educational system. And how are we going to do that? Next slide. So let me tell you a little bit about this space, the Moroccan Initiative for Space Industry. It's a bunch of people who have no time, very busy, but still passionate, got together, and we have people from the US. I come from New Hampshire. We have people from Switzerland, Sweden, France, Italy, and here in Morocco. We come from space science and engineering, STEAM education, IT, academia, rocket science, and entrepreneurship. So space industry, a lot of people think that you need to do physics and engineering to do space. No, that's not true. You can be part of the space industry no matter what you do. You can be an artist, you can be a writer, you can be a doctor, a farmer. You can be part of the industry. Carry on. So our goals, we strive to realize that vision of bringing the space industry to our schools and advocate for it by developing a dynamic fix of high quality scientific education mixed with hands-on. Hands-on, not just memorizing. We need to apply what we teach kids in the laboratories. And we can do it without spending millions of dollars. We can do it with simple methods, as we can show you here in this project, the ExoLab More 1. We're using innovative approaches, and it enables to get the hands-on experience with astronomy, space-related activities, and we use different strategies to get these kids to ignite their curiosity. We want to get their interest and keep it. The most interesting thing is ignite it, but keep it lit, not just for a few seconds or a few years and then lose the interest. Next. This is the ExoLab that I've been talking about it. It's a growing chamber. It's a 2U size. If you don't know what a 2U, there is a CubeSat, which size is 10 centimeter cubes, 10 by 10 by 10, and we call it 1 unit. This farming box is a 2U. And as you can see in the picture over there on the right, yeah, that's the right. There are two growing tubes where we plant seeds. The students plant seeds. And over here, there is an LED panel where students can vary lights intensity and colors. There is a carbon dioxide sensor, temperature sensors, light sensors. There is a camera that takes a picture of the progress once every hour. So the kids, the students get to grow seeds and we'll talk about what kind of seeds later on. And they get to change variables. We teach them about the scientific method, how you can have a hypothesis. And we teach them about design of experiment, what variables you might change to capture the results, and then give us reports. So the scientific method is the base of everything. And one of our mission is to teach it to students at an early age so they can progress with it instilled in them. Not just memorizing, no, analyzing. Next, please. So in this year, we're growing alfalfa. And the XLab experiment also, all the sensors and the camera is accompanied with a very intuitive learning management system that the educators can use to create lessons plans, modified depending on the progress of their students. The students can access and capture their progress and compare with other schools globally. This program is in the US, is in Germany, is in many countries in Africa, Senegal, Kenya, is in Australia. So students can compare their progress with all these participating schools across the globe. And it is designed to help students become familiar with climate change, which if you came in here and you drove, it was not a lot of green. Things are dry. And that's because of climate change. So, and we teach them how to find solution by experimenting with alfalfa plants on a small scale in classroom, like how much carbon monoxide that plants capture. How can we make it capture more? How can we use less water? So they get to learn all about these techniques. And they also use their local soils and compare soils globally. Why is this soil better than the other soil? What makes soil from Sudan better than any other soil in the globe? Why? Why is the soil from Gulmim does not help? And how can we fix that? Because we're gonna go to the moon. We're gonna need some food over there. We're not gonna be shipping it. It's expensive. We all know how expensive launching anything to space. So learning about your local soil and how you can make it better is part of solving space-related problems. And that's the beauty of space education. Next, please. So the ground tile is intended to be supplemented to the Moroccan curriculum. It's not some program that we brought and it's new to the students. No, it was designed to go along with the curriculum that students follow in school. And it's flexible. Like some schools are more advanced than others, and that's the beauty of the LMS. The educator can design it and align it however they see fit. And unfortunately, we started a little late with the program last year with 2 schools in Gulmim Wed Noon. It was toward the end of their semester. So we didn't get to cover many subjects, but we at least focus on science in space, experimental design, carbon cycles, soils, plant physiology, and data, biomass collection. And you can see over there, those are the LMS I was talking about. And those are a few experiments from across the globe, how students can see them, which one is growing better. And they have information, like they log in information, the altitude, the pinpoint location, and what variables they use, so can they learn from each other. Next. Again, is another picture. Actually, this one here is, I think it's in space. Yes. This one here on the right was in the ISS. Students gets to compare their experiment to the same experiment that gets shipped, flown to the ISS. Keep going. So after the inauguration, weekly session. So we inaugurated this at the beginning of last summer. So after inauguration, we held weekly sessions with students to go over the LMS, focusing on lab safety, experiment setup and design. The students were tasked to ask the following questions. What do plants need to grow? How much light the plant need? Why is soil so different from place to place? What environment factors could affect growth? What data should be collected throughout the experiment? And what variable do you want to set? As I said, we want them to think scientifically. So we ask them to answer those questions before they start. They did a ground trial at home. We gave them tubes, soil. We gave them a controlled soil that we get from laboratories from the US, and we ask them to use that controlled soil and use local soil. And we ask them just have theories, have hypotheses, work, and give us reports. And those reports, we're going to use them for the flight trial. Next. So the first ground trial was concluded. Student reports to their teachers using supplied report templates that are accessible in the LMS. The submitted report demonstrated that the students understood the design of experiment by indicating location of local soil, use temperature variation during the experiment, and supplied rationale for the reasons why the experiments were either a success or a failure. Many of them failed, and we thought that failure is okay. This is an important lesson that not many students understand. It is okay to fail, but what did you learn from that failure? And the reports were amazing because they were telling us, why, maybe it was too dry, maybe I give it too much light. I'm like, all right, great. Now you get to do it again and learn from your experiment. So we inaugurated the second, because the launch, I'm getting ahead of myself, but I'm gonna stop here. So this experiment, when we get the ground trials, we launched the same experiment, exactly the same, to the ISS, to the International Space Station, where astronauts plug it in, it has the camera, it takes a picture, it has a set of variables that we took from the students' recommendation. What do you think we should do in space? And then they start their, not ground trial, the same flight trial in the classroom. They have the box, now they start it at the same time. And they compare day by day. The experiment will stay in the ISS for 45 days. And then it's gonna splash down, come back to us for analysis at the university level. So we're working with high school students and university. So now they get to do it again because the launch got delayed. The launch was gonna be happening after Artemis, and Artemis, as you know, kept being pushed and pushed. So since it kept being pushed, we asked them to do another ground trial and see if they can fix some of the problems. So they're doing that now. And by the way, the launch is tomorrow, and the students are gonna watch it live. And after docking, they're gonna watch it live. And when the astronaut is gonna hook it up, they're gonna be live with the astronaut, and the astronaut is gonna talk to them. So just imagine you're in Sahara, and you're connected with an astronaut who's plugging your experiment, and you see your Moroccan flag right there in the ISS, and you are the reason your Moroccan flag is there. Just imagine that. Just picture it with me. So just after the first ground trial, we already started seeing that light coming up. Students started YouTube channel talking about space and ISS and their interest in space just after the ground trial. Before we even they saw the launch, they were so excited. The messages we get, we the MESI members from the students are their parents, is the reason we keep going. Just thinking about them makes us go to work every day. Next. So what's next? Another ground trial. They're doing it right now. ExoLab flight mission with SpaceX Falcon was supposed to be today, got delayed till tomorrow. That's the nation of space industry. We got used to it. And then comparison of in-class experiment versus ISS. That's what's going to happen for the next 45 days. But what's really next is expanding this program. We started with two high schools, and we're looking for the next year to expand more in other regions. We have some friends here from La'youn who's going to assist us to implement it in La'youn. Shout out to you guys. Thank you for being here with us. This work takes a lot of work in the ground, and we need help. And we started seeing requests for help. And thank you for everyone who's asking to help. And maybe expanding, not just teaching them about the plants, maybe teaching them about sensors, how they function, how to program them. Now we can move to communication, board design, and all that stuff. So those are the next phases. And again, this is one of the programs. MISI was started just 1 year ago. We already did 4 beautiful projects. And after this event, actually, we're supposed to meet and discuss a slew of projects that we have lined up. And hopefully we can keep this going. Please reach out if you want to know more, if you want to help, if you want to sponsor, if you want to do anything. We look for everything. Thank you for being here. Enjoy this event.
Thank you, Nofal. I think we're gonna merge this keynote speech with our panel discussion, which is in the same context about capacity building and outreach in Africa. So I'd like to have you, Nofal, still with us? All right, yeah. And I'd also like to welcome Dr. Islam Abul Magd, Deputy CEO from the Egyptian Space Agency. We also have with us at Tariq Foundation for Meteoritics and the Planetary Science, Professor Hasna Ashinawi. Thank you for your patience. We just need our speakers on stage with us. But if Dr. Islam Abul Magd would like to have a word, it's.
Good morning, everybody. I'm really happy to be here with you today. I've been kindly invited by the African Generation Space Group, who are giving the ambitious and momentum to all African youth for the space technology, space applications. I'm very glad to be here with you today and tomorrow for this 2 days workshop that will talk together with other partners from other countries of the world, from Europe, from the United States of America, from all of the continent, to talk together and see how we leverage this space capacity in Africa, how to strengthen our technology in Africa. I'm looking forward talking to you and our panel with my colleagues and the presentations and discussions. Thank you very much and looking forward to the panel discussion. Thank you.
So Professor Hasna Shinawi is joining us as well on this panel discussion. So I leave you to start and maybe inspire all the amazing people who are so passionate here today. And yeah.
Yep. Is this working? Hello, everyone. Nice having you on stage. Yeah. So welcome. We're going to start the panel discussion about outreach and capacity building. Outreach is very important. NASA does a lot of outreach. I'm impressed with the outreach NASA does, by the way. It's impressive. And we have here some experts that we can discuss how can do more outreach and how we can make it in countries like Morocco and other countries in Africa. How can we have a thriving space industry? Where do we start? What do we do? We start from politics. It's very important. The regulatory frames. Where do we start? How we can kickstart it? Literally, that is the main question I have in mind. My initiative is the Moroccan Initiative for Space Industry. And my question, okay, I'm doing outreach now. What's next? How can I have a startup? How can I have some of the students here joining the industry without leaving this country, without leaving this continent, without joining ESA or NASA or all the wonderful, it is a boom in the space industry right now, you know it more than I. But how can we do it from here? Without migrating, without sacrificing, leaving your parents? That's my main question. And let's start with you and then we move on. And you can pick it up from any angle you want.
Okay, well, you mentioned politics, and it's often a dirty word, but it is where the money comes from ultimately. And that is a job that can be difficult for a country that is just starting out or is nascent in its space industry. Why should we, as you may often hear, or people have this perception that a space program is, shooting money into space. Of course, I tell people you can't spend a single dollar or a single dirham in space. There's nowhere to put that money in space. All the money that is spent on space activities is spent on Earth. So you must sometimes convince people that you're not sending money away. That money is staying here. It is making new jobs, high-paying jobs for the country in which the activity is going. So I think that's one part of a message you have to take to your funding organizations, and they may be government, or even if you're going to convince industry to get involved in something. So you can use just the inherent fascination with space. Sometimes people hear me say astronomy is a gateway science. It gets people interested, but you can get also very practical information from space when you look back at Earth. So you can get immediate practical benefits, and those immediate economic benefits are recognized because that money you spent on space is actually spent on the ground, giving better education, allowing people to, they buy cars, they buy houses, they buy washing machines. So all that money, it never actually leaves the planet. It just goes here and recirculates and lifts everyone.
Thank you. Thank you so much.
Oh, thank you very much for this critical questions about how to make capacity building in space and developing countries and in Africa in particular. And I think I'll start with believing in space. If you believe in space and how much turnover you would return from space on a politician level and even on a student level, this would put you change the mindset, how to think about the space industry, how to think about the space services and the products. Everyone in the room is using space, and his cell phone for communication, and his media forecasting for watching TV, and Earth observation in James Webb nice pictures about what in Earth in the space. So I believe believing in space is quite essential. And I think in Africa, if you look to the 55 member states, the mindset has changed in the last 10 years. I've been involved since 2012 in developing the space policy and strategy, and we met a lot of politicians, and they start to think about it, change their mind about it. The new curriculum of STEM played a role. in engineering and mathematics, how to encourage students, and open science is another bridge to leverage the capacity. Even the youth and the students and the new generation in Africa, they start to think about education and space education. This is why you got the African generation space group, this is the sixth event. This means that they started as early as possible, and they thought about it, how to increase the capacity, increase the knowledge, and transfer. And I think most of the countries in Africa now start to spend money in space. Believing in space, we're still very far from James Webb technology and some things, but at least we start to design, assembly, and test satellites for Earth observation, for communication. So this means you do need the capacity for human resources that do that. So internship from our partners in Europe and America, universities like International Rabat University to host this event. They believe in space. So all these things is gonna to increase the capacity development along Africa and among the youth. I also call the national space agencies from Africa to start think about how to network and meet internships, training courses, collaborative events for students and academia. I think this kind of understanding and both like a continental strategy on how to increase this capacity would be great. I hope from this event what come out, and I'll give you some examples later on, how internally in Africa, with the support of our partners, to increase the capacity and change the mindset of our politician. Thank you.
Thank you.
Okay. So, good morning. I will share something very practical. I have to show you what we are doing in At-Tariq Foundation.
Please do.
Yes. Thank you. As your question was very direct and practical, I want to how can we do
Sorry.
You need my help or you're fine? You need my help or you're fine? No, but you have to talk about me. That's what is in the agenda. You're representing me, so you're talking about me.
So again, good morning, everyone. Thank you so much for the opportunity to share some of our practical activities in At-Tariq Foundation. And I'm so happy to be there today. And thank you so much for the invitation again. So this is in a very short presentation, less than 5 minutes, about what we are doing with At-Tariq Foundation. That is very, as I said, practical thing. So At-Tariq Foundation is an NGO that was created on 2019. And it has different objectives. I'll show you from the beginning, because it's a history that began more than 20 years ago, 22 years exactly ago, beginning by how we know that we have many meteorites that are falling in Morocco or collected in Morocco, and a lot of scientific work in the Hassan II University of Casablanca. So in the beginning, I was alone, but now I have many PhD students that some of them already defended their thesis, and some are preparing their thesis. Two of them are there, Sukaina and Mehdi. And many meteorites that wasn't known and that didn't have the privilege to have the Moroccan identity, because all meteorites that was collected in Morocco was just exported without the origin. So we worked a lot as worked a lot as a researcher to, of course, doing the research and publications that make the work that we are doing very credible. We worked a lot on the formation. Now in all the universities in Morocco for more than 10 years, we have a course for the students on Earth and Planetary Science bachelor, having a cosmochemistry course, and we worked a lot on communication, media, TV, newspapers, etc., to make Moroccan people aware about their richness, and to make politicians, we are working about talking about this, and deciders knowing about what we have in Morocco. So we created, as I said, after all this long work, we decided to create this NGO to make us able to do more work, practical work, with youth, with children, with people, than with the head of only the university. We had to have something allowing us to work more generally with more people, including people that are not researchers at the university. So that's why we created this NGO that have, as I said, 4 objectives: promoting meteoritics and planetary science research in Morocco, but also abroad in the Arab countries and in Africa, valorizing the Moroccan geoheritage, disseminating science among youth and the general public, and developing Moroccan territories by developing astrotourism and geotourism. And so those are some of the work that we are doing with children. This was in Ait Ben Haddo. This is, I will just speak about our museum. This is some of our work out of Morocco. This was in Tunisia. I went to Egypt. So different countries to promote meteoritics and planetary science in those countries, as the map you showed about the teams working on James Webb was very, it's very clear that there are a lack of researchers in some parts of the world, and we are working on this, at least on meteoritics and planetary science. Just a few words about one thing that we have now. We have an exhibit, a museum exhibit that is running now in Casablanca, in a mall, in a commercial mall. It's not very common, but we have the opportunity to have this place. And we are doing an exhibit of meteorites, Moroccan meteorites, wonderful meteorites, but also we have dinosaurs, we have minerals, we have some tools for talking about space exploration. We have the Apollo mission that was given by the US Embassy, etc. And we had a previous one that was in Anfa Place that worked for 1 year and welcomed more than 50,000 visitors, including 100 schools. So, and as I told, when we are talking about dinosaurs, about meteorites, everyone have, and especially children, have their eyes open and ears opened. For the outreach, I took my pencil and I wrote one storybook about one meteorite that fell in Morocco on 2008, and the name is Tamdart, and it was in French, and now it's translated in English. And this is very easy to read. It's very well illustrated, but you learn in a very ludic way. So that's our exhibit, and I will just let you with this. And we are here. We have a booth, and if you have any questions, and please, if you have the opportunity to come visit in the exhibit, it's running in Casablanca. So welcome to visit it. Thank you.
Thank you so much. Yes. So this is great. It's part of outreach, and capacity building starts with outreach. Thank you for showing us and sharing with us what you guys do. I think it's amazing. It gets what I was talking about. It gets the light gone. But one thing is very important in the space industry, and you touched on it briefly, with this international cooperation, Space Webb, with many countries. And you have touched on it briefly. You said cooperation. We have, in North Africa, for example, we have great location, this vast desert where you can, near the equator, when you can start launching rockets. Spaceport is a big endeavor. It's not simple, needs a lot of funding, needs a lot of logistics. And how can we bring, well, spaceport and launching is one example, but how can we bring about this international cooperation to make a successful space agency? The US is alone, is 50 states. Even if they stay inside, they are cooperating with each other. They work with all universities. I work with universities. Before coming here, I was at Graz with IWF. And before that, I was in London, the Royal London College. And we all work together to bring these instruments. So how can we do it? How can I work with Egypt and Algeria and Tunisia? And where do we start? How can we get beyond our problems and differences? How do you guys do it? How can we learn from you? What is the tip? How can I work with you, with Egypt tomorrow? How can we start doing that? I think it's very important. So, yeah, please. You can see some lights. Yeah.
There we go. Okay, I think the battery went to sleep there. So collaboration is actually pretty easy among scientists. That happens more natively than cooperation to put hardware together. And that, I think, is a bigger challenge for countries who are nurturing their space industry. Because you're scientists, you can collaborate virtually, you can go to conferences. I think the challenge really is getting industry to find partner industries that it can work with in other countries, because then you start to grow your industrial base in a way that the academic base already has built-in methods to collaborate. Of course, now academicians collaborate pretty easily because there's very little money flowing, and so there's it's easy to talk when there aren't contracts involved. So some of the challenge that NASA faces, even when we work with our typical partners, Canadian Space Agency, European Space Agency, are those contractual things. How do the laws in each country affect how you can collaborate? In some areas, it's very easy, and for some certain sensitive technologies, it becomes hard to collaborate, and that's not easy. But if you start with the scientists who have built-in collaboration, and maybe you start like your example with CubeSats, small groups of scientists involved with small groups of engineers, and that's how you grow that engineering base from the ease of the scientific collaboration. So that's an initial thought there. Happy to hear others, yeah.
Okay, thank you very much. I think industry and collaboration should work in Africa in two levels, on a continental level and on a national level. On a continental level, if you look to the space policy and strategy, which has been adopted by the head of member states, there are three pillars. One for the capacity building and how to leverage the capacity in all Africa, and one for the international collaboration and how to collaborate together for joint projects, and industrial improve the industrial space industry in Africa. To do that in a continental level, we have to start in a national level, how to collaborate together on a space agency by space agency. If I speak on my mind as Egyptian Space Agency, we do 2 projects with 6 African member states. We do 6 EU satellite with 6 member states countries along Africa. And we kicked off the meeting last year, and we bought the subsystems, who will do what, and who will cost what, and who will launch, and when it will be launched, and the mission itself, what the mission itself will serve Africa. When you start this on individual basis, it makes some exercise or success stories that could be repeated with other African member states. I think this is a start point, how to Morocco with Egypt, with Algeria, with South Africa, with Nigeria, for example, to do collectively something in a couple of years. This will strengthen the capacity. This will strengthen the cooperation. This will give a mission that serve African needs and requirements. It will also exchange knowledge and experience. It will also help the local space industry. I think starting from this point till the African Space Agency play its role, supposed to be start operable next year. Supposed to be this year, 2022, but due to a lot of problem barriers, it's going to be in 2023. I think this will play a role on a continental level, how to push forward all these things together, how to cooperate between member states, how to make a continental program, how to make a continental mission, how to increase the capacity among African. We do have the gap analysis for everything in space in Africa. We know what is the limitation we have. So we need to start cooperate together to make some changes in Africa. Thank you.
Thank you.
Oh, so I would be back to Morocco, and I totally agree with you. It's very easy to have scientific collaboration. Of course, you have to have a good scientific work to be known and recognized in the international level. And by this way, it's very easy to have to be welcome in any lab in the world. But what is, in my opinion, very important for Morocco, for Africa, is to have a generation of youth, of scientists that are well trained. And I'm very happy that there are so many youth and young researchers here, because it's, in my opinion, it's the beginning, and it's the first step is to have the people that may bring this topic on the good way, and just having the good researchers, young researchers, well trained in their countries and abroad. And so I think at least for my PhD students, even they are in the Moroccan universities, they are welcomed in US, they are welcome in UK, in Australia, etc. There is no frontier. But we have to have good researchers. And there is something also very important. It's the lobbying. We have to be visible and we have to show why is it so important to take those topics in account and to develop those topics. Because otherwise, for people, when you talk about those topics, everyone is very interested and say, yes, wonderful, you are doing a very good job, etc. But and then why? What will be the benefit of the country about this? So I think we should be more visible. We should explain more why is it important, and for different levels, and to do lobbying to make those topics more visible and more hearable. I don't know how to express this in English, and to be more easy. No, just to make people, deciders, aware about those things and why is it so important. That's it. And for me, it's the three things that I think we should work on.
Okay, thank you so much. I'm gonna start from one last point, link it to a point that you both discussed, which is, okay, how can we convince industry this is beneficial? What's in it for me? What we call it the WIFM. What's in it for me? And you both touch on the importance the scientific community is already cooperating, but we need the industry to cooperate at the local level, national level, and then across borders. But space industry, even outreach, it needs money, it needs funds. And one of the main funds, if it's not government, if you're not there yet, is the industry. The industry that do the outreach, that go and spend some of their, taxable money to fund projects with universities, CubeSats. So in a country like Morocco, Egypt is a little more far there, space industry. I looked at your programs and all that. I'm proud of you, by the way. How can I convince the industry, local industry, this is beneficial for you to give to space industry programs? How can I bring that about? And actually have a consortium of industry, of companies to both help the education and outreach and bring the message to them. Every dollar you spend here is beneficial to you. This youth over here, they're going to come and work for you and make your processes. They might not end up working in a satellite company or a space agency, but space education, whatever they do, it's beneficial to your company in the long term. How can we do that? How can we explain that? A lot of people think, oh, well, we have hungry people here and we're spending $10 billion on James Webb. Well, James Webb is going to save your life 50 years from now. Maybe you or your grandchild's life, we're going to know stuff. How can we bring that message? How can we simplify it? That's my question.
So industry, even in the US, doesn't make money off science experiments, even though people have heard the figure of James Webb costing, it actually cost $8.8 billion to build in the US. That doesn't count what it cost in Europe or in Canada. By the end of the mission, it will be $10 billion. Northrop Grumman was our primary contractor. They don't make a lot of money off science experiments. So when you're talking about convincing industry, we can't just use the science, even though that's more or less the carrot that we dangle in front of them. That it's just one carrot. It won't feed many people. But you have to get these industries who are doing other sorts of high-tech things, tell them they can be part of the space sector. And, unfortunately, in the US, many of these are defense companies. They are where that's where the big money comes from. They don't make it off astronomy. But if you can tie industries that have high-tech needs that are applicable to very practical things. And actually Earth observing satellites, they can be considered very practical. So that's something you can tell somebody, look, if I can return you data about water usage on your land, about how erosion is affecting you, that's immediately sellable to politicians, to businesses, to people who do farming. So you need to link the industry practical side, but you can use perhaps the space side to say, here, not only do you build these electronic components that can tell people how they may farm better or how they can use ocean resources better, but those same electronics can be used on things that discover things in the sky. And so you can tell them that technology is not just single use. A dual use. And it's easy for some things like electronics or maybe how you control thermal flows throughout it. For some things, big mirrors, for example, well, that's pretty specific use there. But I think, again, to start the industry, you need to start at components that have multiple uses. That would be one thing I would suggest.
Thank you.
Oh, thank you very much. I think I concur with what you just have said. I think we made a couple of exercises to see how the industry would be engaged, and because there is no pure space industry. So, for example, the mechanical testing. When we go with the mechanical testing, so we convince the industry that this works for a lot of engineering products. It's not just for space, but it needs just qualifications extra that qualify the space, but still use the same device would be used for a lot of engineering. Other exercise we made is the government invested in a collation of 10 partners, and it was a must to have at least 2 industrial sectors for this collation to end up with design, assembly and test and launch satellite. So they didn't spend money, they took the money from the government, but again, they got involved in the process to see what the gaps is and what they can improve their industry and what other equipment they could get in their facilities to offer service to the space industry or to make some space. But for the application, as you just said, it's just an easygoing to use the satellite data and provide services to the stakeholders and end users, which make money and provide service. And a lot of private sector is running now on the Earth observation applications. One last example exercise, a startup. I do host 5 startups this year for different ideas and different space component. If they succeeded, I do invest in these startups and I give them training and learning and technology and money. If they grow up, if I succeeded by just one startup to end up as a company, this would make a good exercise for the space industry. I think there's a lot of things that we could do that try to engage the private sector and industry, because they always look at how to earn money without spending any efforts. If you give him that, you come to space and get a technology and you get that equipment and the facilities that bloody hell cost you a lot of money, but you will medium long-term investment. He doesn't get into such a process easily. But another idea we are thinking about it now, how to make a joint venture between the government and investor. If the government with the investor make something together, this would he will get the confidence and get the power from the government as a share, and he will invest the money and see as a long-term and medium-term process. I think this is kind of what we are steps taken in Egyptian Space Agency and in Egypt to boost this sector. Thank you.
Fantastic. Thank you.
Okay, so I think that big programs should be, it belongs to nations. So I think that the nation or government, you can, I don't think that we can develop this topic especially only with the industrials. I think that it should really be in the government decisions, and then industries, etc., may help, but it should be in the nation vision. It's not a people vision, it's a nation vision. But if we are back to outreach, that is the panel now. When we begin with At-Tariq, it was just very difficult because we don't have any funds from anywhere. It's our private funds. And we had one meeting with an incredible guy, Moroccan guy, that is Adnan Addiwi, that says that convince us that we should make money with our work, with our NGO. It's very difficult for a scientist, and he says, just think about what we can do and generate not a lot of money, but a little bit money to make your outreach possible, because otherwise it will not be sustainable. So, and we begin working on this, and the exhibit is one part of this, because it's a lot of work, a lot of money, some support from sponsors, but with the visitors, they are paying a fee. Those very small fees, we are using them for the activities, for the paying the travels for students, for the outreach things that we are doing. So I think that we should just differentiate between the big programs that needs to have scientists, that's it, but that needs to have the nation vision, and it's what is happening, for example, in Emirates or something, where they have this fantastic initiative of Marsh, etc. So, but it should be a nation vision, in the nation vision, and for the small initiatives, we have to think differently from just having the support of industrials or others, and begin thinking about how making not money for themselves, but money for the purpose of the NGO, or the purpose of the people that want to develop those topics. That's it. Thank you.
Awesome. Thank you so much. Well, I wish we can just have all day and discuss capacity building here. I can't get enough of it, but we're on a schedule. Mr. Serhan is saying we have to move on. Thank you so much for your time and your answers. And let's do something about it. Let's do something about it. Keep doing what you're doing. Thank you.
I'm sure the conversation. I'm sure the conversation will not stop here, and many works will come in the very near future. So the day is long, but before proceeding with any further keynote speech or panel, we would like you to have like a little break. You have like some delights and some drinks. So let's meet in 10 minutes.